Because the electromagnetic waves are all traveling at the speed of light, supposedly the wavelength and the frequency of the light have a direct relationship. If the wavelength is short, many waves pass a reference point per given amount of time and the frequency is high. If the wavelength is long, fewer waves pass the reference point during the same amount of time and the frequency is lower. You can see the relationship between the wavelength and the frequency with this equation. Lambda V equals C, where lambda is the wavelength in meters, V is the frequency, and C is the speed of light. In working problems with this direct relationship between wavelength and frequency, expressing the wavelength, frequency, and speed of light in the units of meters, cycles per second, and meters per second is easiest. Notice that gamma rays have the shortest wavelength or highest frequency and radio waves have the longest wavelength, lowest frequency. Also notice the visible spectrum, the part of the electromagnetic spectrum that you can detect with your eyes, is a relatively small part of the entire electromagnetic spectrum. Scientists generally express the wavelength of the visible part of the spectrum in nanometers, and the wavelength ranges from violet at about 400 nanometers to red at 750 nanometers.